Well, hello and welcome back to Mr. Reed Math, where we're going to take the mystery in math and we're going to make that past tense. And you know what? I'd like to make something else past tense too. NTI, I think I'm there. 3 days in a row of non-traditional instruction. I am ready to get us all back in the classroom. How do you all feel about that? All right, well, let's get through one more day of good, solid NTI instruction. What have we done so far with it? 3 days in a row. The first day, we talked about parallelograms, and you all learned how to find the perimeter and the area of parallelograms, and did great. All right, and then the next day, we talked about triangles. That's yesterday. And now today, we're going to extend that, rhombuses and kites. All right, so we're going to talk about them for a second. And what do they look like? Don't you want to know? Well, here's a picture of a hastily drawn rhombus and a hastily drawn kite. All right, the big things that the dead giveaways are with the rhombus, you're going to have four sides that are all marked congruent. All right, and you're going to have this intersection in the middle where they're all 90 degrees. Okay, and with a kite, you're going to have pairs of congruent side lengths. They're consecutive and they're congruent, consecutive side lengths and congruent. All right, and again, you're going to have this relationship in the middle where all the intersections are 90 degrees. Okay, so rhombus and kite. And we need to be able to, number one, find the perimeter, which just like the parallelogram, just like the triangle, I don't really want to spend any time on that because it's super simple. You go around the outside and you count the distance. If each one of these was 8 inches long, that's 8 inches, that's 16 inches, that's 24 inches, 32 inches, that would be your perimeter. I would just say 32 inches. I would not say 32 inches squared. All right, perimeter is just the straight line distance. Same thing with a kite. If that was 5 inches and that was 11 inches, well then I would have 5 inches, 16 inches, 27 inches, 32 inches. That would be your perimeter. Okay? All right, but now the area. What do we do about the area with these things? Okay, well it's a little, we don't have these, with the kite especially, we don't have all these parallel lines, and man, I don't know, I'm stumped. Let me see, with parallelograms, okay, so we took the height of the parallelogram and we took the base of the parallelogram and we multiplied them times each other, or multiplied them, and that was the area. So if you had a base of 10 and a height of 8, then the area was 80 units squared. Triangles, you take the base or the side you're working with and you take the altitude from that side and then you divide by 2, right? So if your side length was 6 and your altitude was 4, then that'd be 24, and then you would divide by 2 and you end up with an area of 12 for that triangle. Okay, this one, when I look at it, well, think about it. What do you see a lot of in these two pictures? I don't know about you, but I see a lot of triangles. And right off the bat, if it came down to it, what did I tell you at the beginning of the year? I said, when we started getting into triangles, I said, these are really the fundamental unit of geometry. All right, it starts with triangles. And I'll tell you right now, if you've got enough information, if you know the length of that piece and that piece and that piece, if you have all the lengths that you need, and you want to calculate the area of that triangle, add it to that triangle, add it to that, you can do that, and you'll get the same value as if you use the trick that I'm going to teach you in just a minute. Okay, but let's see what that looks like. Now, I'll tell you this, and I need you to trust me in the interest of time. The way we find the area of a rhombus is exactly the same as the way we find the area of a kite. Okay, there's no difference. Honestly, a rhombus is a kite. And some kites are rhombuses, but not all of them. Okay, but a rhombus is always a kite. Okay, so we're going to deal with a rhombus, and I'm going to show you how to find the area of that rhombus. Okay, so let's take an example. Here we go. Mr. Rhombus here. All right, now, first of all, how do we show the length of a rhombus? How do we measure it? And one of the easiest things to represent is either just to mark the side lengths, which you would need for perimeter, or to mark the diagonals, okay? And there's a hint to how we're going to solve these things, okay? I'm not going to give it completely away right now, but marking the diagonals is key. All right, so this diagonal right here, this line off to the side tells us that this line is 8 units long. Right, this diagonal right here, well, this marking up above it might be below, wherever, but this marking above it says that that's 14 inches or 14 units. Okay, so that's the rhombus we're going to work with. Now let's pull in an arrangement that, okay, well, I know how to find the area of triangles. So why don't let's just break it down into two triangles side by side like that. Would that work? Well, let me see. I know that this length is 8, so I know that that side of the triangle is 8. And I also know that from this point straight across to this point, see, that would be the altitude of the triangle from that side. So this altitude, just like I marked down here, is going to be 7. So the way I would find the area of that triangle is I would take the side, multiply it times the altitude, and then divide by 2. So 8 times 7 is 56, divided by 2 equals 28. Paper's moving on me, sorry. Okay, so that's this triangle. Okay, now to find this triangle, well, I got news for you. It's going to be the same because it's a rhombus. But let's just go through the numbers here. 8 times the altitude of 7, that would be 56, divided by 2. Oh, what do you know? That also equals 28. Crazy, okay? Far out. Okay, now I add those two together, well, I get 56 again, okay? So 56 ends up being the area of this triangle plus this triangle. So the area of the rhombus is 56. Whoa, cool. All right, well, let's hang on to that one. All right, we're going to need it. But let's see. Okay, so this is how you can take it. You can break it apart into two triangles, solve the triangles, and that gives you the area. But wait, there's more. What if, instead of breaking it down into two triangles, let me see if I can get the paper to come apart. All right, I broke it down into 4 triangles. Oh my gosh. Okay, well, yeah, that should work too. I mean, if the math is good. So let's see, what would that give us? Okay, well, this height right here would be 4, and half of that would be 7. So each one of those triangles, and because it's a right triangle, the altitude is the side. They're the same. So the altitude is 4, and the side we're going to use to measure the altitude from is 7. So I take 7 times 4, that equals 28. I'm going to divide by 2 to get the area of this triangle, which would be 14. Boom. So that means that this one is 14, this one's 14, this one's 14, and this one's 14. You can do this with a rhombus. You can't do this with a kite, okay? But you can do this with a rhombus. So 14, 14, 14, 14. Okay, so if I add all those together, I end up getting 56. Well, wait a minute. That sounds familiar. 56, 56. Hey, the area of the rhombus, we've now proved it 2 different ways with triangles. The area of the rhombus is 56. Cool. All right. So that's what we're going to do, right? I don't know. Why would you want to do that? That's a lot of work. I don't understand. Okay, that's too much work for me. I want something easier. There's got to be a shortcut in this. And wouldn't you know, yes, there is. Okay, let's look at these. And remember, I told you this was key. Now, if I take this number here for this diagonal, and I take this number here for this diagonal, well, what if I multiplied those together? Let's try that. All right, 8 times 14, that's 112, right? 8 times 14, 80 plus 32, yeah, 112. Okay, all right, cool. And okay, well, then I have to divide by 2. All right, that's the other part of the shortcut. You take the diagonal, you multiply it times the diagonal, and you divide by 2. So what happens if I get 112 divided by 2? That's an awful looking division symbol. And I get 56. Oh my gosh. It's the same as that right there. Oh my gosh. And the same as right there. Sweet. Okay, so we have a shortcut. This is how you find anytime you have a kite or a rhombus. You take the length of one diagonal, you multiply it by the length of the other diagonal, and you divide by 2, and you get the area for the entire rhombus. For a kite, you take the length of the diagonal, you multiply it times the length of the other diagonal, and then you divide by 2, and then you get the area for the kite. Both of them work the same way. Okay? So let me say that one more time. You take the length of one diagonal, you multiply it by the length of the other diagonal, you divide by 2. Don't skip that step. You've got to divide by 2, and then that gives you the area of the rhombus or of the kite. All right? Really much simpler than this or this, I think. Okay? But hey, folks, if you're comfortable with triangles, if you can see the patterns in there, and you're comfortable doing this, then by all means, do what makes you comfortable if you've got the information that'll let you get there. All right? Sometimes, if you're only going to get a marking that shows you just 1 or 2 pieces of information, like you get the 8 and the 14, and if it's a kite or something, you may not be able to break it down quite as easily. Okay? But length of a diagonal times the length of a diagonal, divide by 2, and that will give you the area of either one of those shapes. But Mr. Reed, What about the rhombusest of all rhombuses? What about, does it work with squares? Because I may have told you in class, I'm pretty sure I did, a square is also a rhombus. All right, which means a square is also a kite. Does it work with a rhombus and a kite? Yes, it does. This square, 10 times 10, has an area of 100. Okay, and the family's getting ready to come in, so you might hear the dogs barking in just a second, and I've only got a couple minutes anyway. So, let me see. So that square has an area of 100 units. Well, that's cool. We're going to set this aside. We're going to use that because I might refer back to that here in just a second. Now, what I want to do is I want to know, can I take the length of this diagonal and multiply it by the length of that diagonal, divide by 2, and also get 100? If so, then that really builds my confidence in this rule. Well, how do I figure out the length of that diagonal? Okay, well, those of you who think back and who can remember our discussions that we had about special right triangles. There was one called a 45, 45, 90 right triangle. Okay, and here we have, all of these are 90 degrees, right? And if I cut that 90 degrees in half, I end up with 45, 45, and 90. So that's a 45, 45, 90 right triangle. All right, and if I have the side lengths of 10 and 10, I told you there's a really easy trick to figure out what the hypotenuse is in that right triangle. The hypotenuse is one of the short legs times the square root of 2. So 10 square root of 2 would be the length of the diagonal. Well, I got news for you. If that diagonal is 10 times square root of 2, let me write it down right there, 10 square root of 2, then guess what? So is this one, because it's a square. Okay? So here's the question. Can I take 10 square root of 2, multiply it times 10 square root of 2, then divide by 2, and get 100? If so, then it works for a square, and this rule is simply awesome. So let's use this space over here to write it down. All right, how do I do this? I take 10 times the square root of 2 times 10 times the square root of 2. All right, and what I do is first I take the numbers and multiply them. So 10 times 10 is 100, and the square root of 2 times the square root of 2 is the same as saying 10 times the square root of 2 squared, if you recall, right? So, and if you remember, when we have a situation like that, boom, boom, those cancel, and we end up with 100 times 2, which equals 200. But wait. 200 is not the 100 that we were looking for. Oh, but wait. We're supposed to divide by 2 at the end of it all. And when we divide 200 by 2, we get 100. And there we go. And Hulk is excited because his family people are home and he's running circles, and a 90-pound dog running circles makes a lot of noise. Okay, so we have proven that not only does it work for kites and for rhombuses, but it also works for squares. There's your rule. Let me say it one more time. You take a diagonal, you multiply it by the other diagonal, and then you divide the whole thing by 2, and that is the area of not only a rhombus, not only a kite, but also, if you want to do it this way, a square. All right, there you go. I can't wait to see you all in the classroom on Monday. I'm going to shut this one down for now. Make sure you do the quizzes. Make sure you score at least 80% on the quizzes, and have a wonderful weekend. I'll see you Monday.